Hi, welcome to the Olympiad geometry. Let's continue our study on the correlation of triangle centers. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So here is a problem. In triangle ABC, angle C equals to 30 degrees. O is the circumcenter, I is the incenter. D is on AC, E is on BC, that AD equals to B equals to AB. Prove that OI is perpendicular to DE and also OI equals to DE. So the first thing that we need to do is to draw the figure and look at the problem that we know the angle C equals to 30 degrees. And angle C, that is a circular circle, which means a circular angle, which means we know that angle AOB equals to 60 degrees, which makes a triangle AOB an equilateral triangle, right? So we can draw the circumcircle first and find the center O, and then we can just find the 60 degree here, and that helps us to find point A and point B. Then we can find any point on the circle. Let's call this point, this C. That forces the angle ACB equals to 30 degrees, right? Okay. Now we know that we have the circumcenter here, and we need to find the incenter, which means we find the angle bisector here, and we find the angle bisector here. Right, call this as I. And we also need to find that D is on AC, E is on BC, so that AD equals to BE equals to AB. And we know AB equals to AO equals to OB equals to the radius of the circumcircle. So that makes AD equals to AO, right? So we can connect it here, that is D. And make DE equals to BO, right? So this is E, and we connect it here. So we know that triangle ADO and triangle EBO are isosceles triangles. Then we connect DE. We want to prove that OI is perpendicular to DE and OI equals to DE. So if we just start from this figure, it becomes a very difficult problem because we don't have a breakpoint. But if you look at the problem set that AD equals to AB, right? AD equals to AB. I is the incenter. That means AI is the angle bisector of angle CAB, which means we know that triangle DAI is congruent to triangle BAI, right? And it forces us to connect ID and IB. Similarly, we know that EB equals to AB, and I is the incenter, which means BI is the angle bisector of angle ABE. So we know that triangle EBI is congruent to triangle ABI, right? Forces us to connect EI here. So we actually know triangle DAI is congruent to triangle BAI and congruent to triangle BAI, right? BEI. Right, so we know that this triangle, and this triangle, they're all congruent, which means angle DIA equals to angle AIB equals to angle BIE equals to the angle AIB, that is angle from the two vertices and with in center, right? So it equals to 90 degree plus half of angle C, right? Half times 30 degree, which means it's 105 degrees, which means the angle DIE can be calculated by 360 minus 3 times 105 equals to 45 degree. Right, that's the angle DIE. Now we think about this problem. We want to prove that IO is perpendicular to DE, and we know that angle DIE equals to 45 degree. And for this figure, it's kind of symmetrical from the C to A or C to B, right? That leads us to a guess. O might be the orthocenter of triangle DIE, right? To prove that, we just need to prove that angle C, if DO is perpendicular to IE, and we already know that angle DIE equals to 45 degree. That means angle ODI equals to 45 degree. So we just need to find the angle ODI now, right? The angle ODI equals to angle ODA minus angle IDA, right? ODI equals to angle ODA minus angle IDA, right? Minus this angle. So let's assume this angle equals to alpha. The angle DAO equals to alpha, right? Then the angle ODA can be written with a variable alpha, right? Because the triangle DAO is an isosceles triangle, that means angle ODA equals to 180 degree minus alpha times half, right? And minus angle IDA equals to angle IBA, right? The angle IBA is half of angle ABC, so minus half of angle ABC, which equals to 180 degree minus alpha times half minus half of, what is angle ABC? Angle ABC is 180 degree minus angle BAC and angle C. Angle C is 30 degree. And angle BAC, that is 60 degree plus alpha, right? So minus 60 degree minus alpha, which makes this to be 90 degree minus half of alpha minus, so this is 90, so that's 90 degree minus alpha, and make it 45 degree plus half of alpha equals to 45 degree. That's great, right? Because we just proved angle ODI equals to 45 degree, and we know that angle DIE equals to 45 degree. So based on these two, we know that DO is perpendicular to IE. Right, DO is perpendicular to IE. And now we want to calculate for the angle OEI, which equals to angle OEB minus angle IEB, which equals to, see, this is alpha. If we connect to CO, we know that angle DAO is alpha, then angle DCO is alpha, right? And because angle DCE is 30 degrees, so the angle OCE is 30 degree minus alpha, right? So this one, 30 degree minus alpha, which makes the angle OBE equals to 30 degree minus alpha, right? Then we can calculate for the angle OEB, right? Because the triangle OEB is an isosceles triangle, so it equals to half of 180 degree minus 30 degree minus alpha, right? And minus the angle IEB. This angle, because triangle IEB is congruent to triangle IAB, so this angle equals to this angle, which is half of angle BAC. So it equals to half of angle BAC, which is 60 degree plus alpha, right? So it equals to, this is 150 degree minus plus alpha, and we times half of it, so we got 75 degree plus half of alpha, and we minus 30 degree minus half of alpha equals to 45 degree. That means OE is perpendicular to DI, right? Then we know that O is isocenter of triangle DEI, right? O is isocenter of triangle DEI. Now we want to prove that OI equals to DE. We need to remind ourselves of property of the isocenter. So here I draw a circle, right? For any triangle here, any triangle, we find the isocenter of this triangle. I think I introduced this property before in the chapter of the property of isocenter, but let's just refresh ourselves of this property. See the triangle ABC and the triangle BHC. If we extend AH meets the circumcircle point on the H prime, we already proved that triangle BHC is congruent to triangle BH prime C, right? That means triangle ABC and triangle BHC has a same or equal circumcircle, right? Triangle ABC and triangle BHC have same circumcircle, which means that in the triangle DEI, for triangle DEI, we know that triangle DEI and triangle DOI have same circumcircle, right? Because O is isocenter of the triangle DEI. Okay, then look at because they have the same circumcircle, that means for the chord DE, right? It refers to the circular angle DIE, which is 45 degree. And for the chord OI, right, in the circumcircle of the triangle ODI, for the chord OI, it refers to the circular angle IDO, which is 45 degree as well. That means IO equals to DE. Okay? So for this problem, I think this is a training problem for the Chinese IMO summer camp. I don't think this is a very easy problem, but it's not too difficult to solve with. I think the most critical part in this problem is that when you realize that you can calculate for the angle AIB, you know the angle DIA, and you know the angle EIB. You know that angle DIE is 45 degree. And based on this, you have to make a guess that OA is the isocenter. Then it leads you to calculate for the angle of angle ODI and angle OEI, and you can easily prove that OE is perpendicular to DI and OD is perpendicular to EI, which means O is isocenter, and that leads IO to be perpendicular with DE. And then you need to have the knowledge of this one, right? To help you easily prove that OI equals to DE, just because they all reference to a same circular angle while the circumcircle are equal. Okay? I hope you like this video. I hope you like this problem. See you in next one. Thank you.